Hi everybody, Mrs. Pesek here. We are looking at section 1.6 called Library of Parent Functions. Your learning objectives are to identify and graph linear and squaring functions, cubic, square root, and reciprocal functions, and step functions and other piecewise functions, and also recognize graphs of parent functions when you see them. So you do have a gift on this, and I want to just start off by looking at step functions. Those graphs look like stair steps. So for example, if we are going to graph this function here, this is a piecewise function, but it's actually just a step function. Why is it just a step? Why is it a step function in addition to a piecewise? Is because these functions, function values that you see here, are all just constants, which means that when you look at your graph, they'll all just be horizontal pieces. So when we graph this first one, we're graphing just y equals 2 for f of x equals 2, and we only want that graph from 0 to 5. So here's that function graph from 0 to 5, like this, but we do want a hole in the graph over on this side and a point over here. So that's my best effort at getting a hole in the graph. Let's see if I can scoot that over a bit. Not that great, but that is a hole in the graph. Hopefully you can see that. And then my next function is going to be graphing y equals 4, but that one we only want from 5 to 10. So we do want this horizontal piece at a height of 4, but again we want a hole in the graph at the order pair 5, 4, and then a point in the graph at 10, 4. And then lastly, we want it to be a height of 6 for this last function, y equals 6, and that's if x is greater than or equal to 10. So that final graph is going to have a hole in the graph there. I'm trying to make a hole in the graph. I don't know what's going on with this function. Trying to get rid of that. So I need a hole in the graph here, and then shading, or not shading, but the horizontal line to the right. All right, so that's our first graph. Let's take a look at the most famous step function. It is called the greatest integer function, and it's denoted by these double bars that you see here around the x. And what does that mean? It means we are always looking for the greatest integer less than or equal to x. So what is the greatest integer less than or equal to 6? Well, that would just be 6. What's the greatest integer less than or equal to 3.5? That would be 3, because that's the integer closest to 3.5 that is less than 3.5, less than or equal to. And for negative 2.1, that would be a negative 3. That's the greatest integer less than or equal to negative 2.1. For example, if here's negative 2 on a number line, here's negative 3 on a number line, and negative 2.1 is, maybe right about here. We want the greatest integer that's less than or equal to negative 2.1. So we would have to actually go down to negative 3, because we don't want to go up to negative 2. That would be greater than negative 2.1. All right, and let's pause for a second and look at the graph. If we look at the graph, I'm going to a graphs page, and on the graph, I am just typing in int. That's the greatest integer function. And let's say I want the greatest integer function just of x. There's my greatest integer function. And actually, let me just zoom in a little bit. Menu, window zoom, window settings, and let's just go from, let's say, negative 4 to 4. And then negative 4 to 4. And let's see. So we're seeing here we have a horizontal piece here between 0 and 1, and then another horizontal piece from 1 to 2, and then another horizontal piece from 2 to 3, and so on. So this is what the greatest integer function looks like. So if we are graphing this by hand, were we graphing this by hand? I guess I didn't put that on here. But if we were graphing this by hand, we would see, I'll just do a quick sketch of this. All right, let's say I got this. And so the graph is going to look like this, we're going to have a point at 0, 0, and then a horizontal section all the way to a hole right at 1. And at 1, the graph jumps up to a height of 1. And then it's going to be a horizontal piece again until we get to an x value of 2. And at that point, it jumps up to 2. And this pattern just keeps going. Right? And same thing, like if I pick a number that's just slightly less than 0, it's going to drop down to -1. So I'm going to have a hole in the graph at 0, -1, and then it's going to go to a point at -1. And so this is what the graph is going to look like. All right, so that means that the domain is going to be all real numbers, -infinity to +infinity. The range is going to be all integers, the set of all integers. The intercepts, if we look at the intercepts on our little graph, I think we see that the y-intercept is right here at 0, 0. So the y-intercept is 0. You write that down. Y-intercept is 0. But what about the x-intercept? So where does the graph cross the x-axis? Well, really, it's this entire piece of the graph right here is touching the x-axis. So all of those points are x-intercepts. So I would say the x-intercepts would be everything from 0 to 1, including the 0, but not including the 1. And that was supposed to say x-intercept. That didn't look so good. All right, so is it increasing, decreasing, or constant? I would say the graph is constant over each piece of its domain. All right, so for example, it's constant between 0 and 1, right? And it's constant between 1 and 2, and it's constant between 2 and 3, and so on. That's what I would say about that. And so now, if we were going to find, oh my goodness, I'm really struggling. Let's see, that doesn't look good. If I was trying to evaluate this h of x, all right, and I'm going to plug in 3.8 in for in for x. So I will have 4 times greatest integer less than or equal to 3.8 minus 3, and then plus 2. All right. And so in order to do that, I need 4 times greatest integer less than or equal to, well, 3.8 minus 3 is 0.8, and then plus 2. So I get that the greatest integer less than 0.8 would be 0. So I get 4 times 0 plus 2, which is just 2. Let's check that on our calculator. So if I go to a calculator, and I'm going to add a calculator page. And I want 4 times greatest integer. Again, I'm going to use int of, and it was I'm just going to use x minus 3, and then outside of that greatest integer, it was plus 2. And I want to figure out what this is evaluated such that x is equal to 3.8. So I'm going to do control equals and pick that such that x equals 3.8. And sure enough, it is equal to 2. So that's how you can do this with your calculator, but I would like you to be able to do it by hand like I just demonstrated, like I just demonstrated here. All right, I'll let you do this one on your own. Let's move on. This time we're graphing this piecewise function. We're graphing the function f of x equaling 2x plus 4. That means 2x plus 4 if x is less than -2. So that's y equals 2x plus 4. The y-intercept is 4, slope is 2, so up 2 to the right 1, up 2 to the right 1, and so on. Down 2 to the left 1, down 2 to the left 1, and so on. So I can draw in this line like this, but I don't want to keep the entire line. I only want to keep the line when it is less than -2. So I can find where is -2. There's -2 on my x-axis. And so I am going to erase everything that is, everything that is greater than -2. So all of this is going away, going away, going away, going away. And so it's just left like this. And let me clear this out for a minute so we can see what's happening. Because right here at -2, 0, we should have a hole in the graph there. So I think I'm going to erase a bit more of this so I can actually draw in a hole in the graph right there. And that means that my graph should look something like this. All right, and I'm going to put this back over here to show where the -2 was. All right, but we do have a hole in the graph there at -2, 0. Now we're ready to graph the next piece of our piecewise function, and that's just y equals 3. So I know that's a little horizontal segment, but it only is supposed to, so it's here at a height of 3, but I don't want that whole horizontal line. I only want it graphed between -2 and 1, including the -2, not including the 1. So again, I'm going to erase all of this from -2, less than -2, and everything, I'm erasing everything that's greater than 1. And I actually want to show that I have a hole in the graph here at 1, 3, but there'll be a point in the graph at -2, 3. All right, and then that brings us to our last piece of our graph, which is y equals -3x plus 8. Okay, so we are graphing y equals -3x plus 8. So the y-intercept is up here at 8, and we need a slope of -3, so that's down 3 to the right 1, down 3 to the right 1, down 3 and to the right 1, and so on. But we don't want this entire line. We only want this line graphed for x's that are greater than or equal to 1. So let's find out where's 1 on our x-axis. There's 1. That means kind of picture is like a little dividing line here. So in other words, the graph is going to start right there and go to the right because we want x is greater than or equal to 1. So I am going to erase what I don't want. So that'd be erasing all of this, erasing all the way down to here. And I do want that to be a point, not a hole, because it's x greater than or equal to 1. And so we should have the graph looking like this. All right, that is our piecewise functions graphed. All right, let's take a look at this one. Now, I do have to say that on your paper, this is marked right, whoopsie, this is marked right here as x less than or equal to -2, but can we just make that a +2? So please change that so this is a +2 here, all right? So we want that looking like this. And so what we have to do now to graph this, I'm going to pull this up here. We're graphing this in 2 pieces. And let's just start out with the first function. And the first function is just y equals 1 minus x minus 1 quantity squared. And we want this for x less than or equal to 2. Now we will learn some more sophisticated methods of graphing this, but for right now, let's just plot some points. I'm going to start with 2 because I want a graph for x less than or equal to 2, and I'm going to take some values that are less than 2. So let's say 2, 1, 0, -1, that kind of thing. So let's actually go to, I know we're going to graph this by hand, but I want to do a little bit of this work on the calculator. So let's do, I'm doing 1 minus x minus 1 squared. So I want 1 minus parentheses x minus 1 close parentheses squared. And I want this, I got to do a little right click to get out of that exponent, I think, maybe not. And then control divided by, I need the such that key. And I want x equals what we're starting with 2, right? And I'm getting 0. So I know that my first ordered pair is 2, 0. Let's get this ordered pair for 1. So if I'm plugging in 1, I can just do up click, enter, and change this to a 1. And I'm getting 1. So the ordered pair is 1, 1. All right, now if I plug in 0, up click, enter, change this to a 0, I'm getting 0. So I have the order pair 0, 0. And let's just do one more. Let's plug in -1. So up click, enter, change this to a -1, and I'm getting -3. So the order pair is -1, -3. So let's go ahead and plot these. So I've got 2, 0, 1, 1, 0, 0, and -1, 1, 2, 3, -3. This is part of a parabola that's opening like this. All right, that's as much as we can see of this parabola. Now let's graph the other piece, which is y equals square root of x minus 2. All right, that's supposed to be my square root. And this time we want it for x is greater than 2. Well, here's the thing. Let's actually start with 2. I know it's supposed to be just x strictly greater than 2, but let's start with 2 because that will tell us where the hole in the graph is going to be. And then we want to go and pick a few values greater than that. So we'll try 2 and 3 and we'll see what we can get. So if I'm going to pick 2 and 3, square root of 2 minus 2 is the square root of 0, which is just 0. And if I try 3, I get square root of 3 minus 2 is the square root of 1, which is 1. And if I want the next nice ordered pair to come out of my square root, I would probably pick 6 instead of 4 or 5. Let's try 6. I get 6 minus 2, that's square root of 4, which is 2. So now I'm going to plot these points starting with 2, 0, which is actually the hole in the graph. All right, but look, that hole in the graph is actually going to be right over the point. And if there's a point and a hole at the same place, well, then the point wins. All right, so this should just be just filled in here. Well, I'll leave this there just to remind us that that was the hole in the graph. But then it's going to 3, 1, which is right there, and 4, 5, 6, 2 is right there. And so this graph is going to look like this. But again, that point and that hole are getting, the hole's getting filled in by the point, so it looks like this. All right, that's it for this graph. That's all we had to do. And I think that's it for this video. All right, so thanks for watching.